Okay, so here we are for Tips and Tricks
We are
5.
going to look at some examples of group and pivot, and we're going to use our Winter Olympic data set. So our Winter Olympic data set contains a number of important columns. So here we can see these revealed. Okay, as we go forward, what we'd like to do is start off by applying the group. The data set here contains over 48,000 rows. Using group and pivot, we can organize the data and analyze it far more effectively. So here, I'd be interested in grouping by the variety of sports here. And using group, we will count the number of events for those sports over the course of the Olympics that are included in this data set. It's actually the number of performances, athlete performances. So here, if we do so, we quickly see, for instance, alpine skiing, 8,829 performances. And then here, this is in alphabetical order in terms of the sport. I think it might be more informative to sort this by the count. Now, the group command created a new table, actually. So this combination here is actually a new table. That new table contains only these two columns, the sport and the count. So now we can sort by the count, and in this case, it would be most effective to use descending equals true here. So here, quickly, we can see cross-country skiing had the most performances, and we can go down the list. So this is quite helpful. You can imagine applying this to a number of other of the columns here and coming up with very informative summary information regarding the data in this very large table. So now we're going to go to a second approach that we can use. This is known as the pivot. The pivot allows us to take two of the columns and examine rows which meet both of the criteria. So, for instance, we're going to look at medal in this case, and we'll start by looking at team. NOC turns out to be a equivalent term. So here, if we pivot by medal, notice the first column, all of the potential labels in that column, these are categorical variables, each of them appear as a new column, with bronze, gold, and silver being the typical medals they awarded. NAN refers to cases where there were performances, but they didn't garner a medal. So really the majority that we will see are cases where NAN, and this is quote NAN, it's a string, are found here. So now we could actually sort this. So for instance, we want to find out which team had the most silver medal performances. We can sort by the silver column, and again, as is typical, want to use the descending equals true here. Okay. So here we see the United States had the most silver medal performances. If we quickly change this to gold, we'll see some alternative information, with Canada showing up top in terms of the gold. So you can see the pivot is really, really powerful for carrying out this kind of analysis of a large data set. Now, with this kind of data, it would be nice to know, for instance, the average for the typical team. How many medals does the typical team earn over the course of the Olympics? So here, 289 is obviously the highest, but we would be interested in understanding what the mean, standard deviation, min, max, and other measures. So to do that, we first develop a function, and this function is going to take the argument of a table. So a table could be athletes, like up here, or since the pivot method generates a table, we could take athletes.pivot and also place it here. So that can be a helpful approach. The column is the label of a column. So for instance, if we're interested in the average number of gold medals, we would put in quotes gold. And then here, this function creates an empty list. The column is placed in an array, and then the empty list is appended with the values generated from the mean, standard deviation, and then you could add additional rows to pick up the min, max, etc. Then we have a fancy print statement which allows you to print the values in addition to those that will be displayed in the array. So let's see this in working. I ran this indicating that there were no errors in running it. So now, for instance, here we can look by team. This is the table that we're putting in to the function in this position, and then this is the medal that we're looking at. So here we can get those stats. So in doing, we find out the mean number of gold medals is 8.66 per team. Standard deviation is quite large because we do have many teams with no medals, and others with the gold medal, we see Canada has as many as 289. These same numbers are captured in the list, which is returned by the function. So here, furthermore, we can also change this. So here, for instance, silver, and have to, of course, type that correctly. So now we'll get a little different value for the silver medals. So this is the idea of applying this. If we wanted to add new measures here, we could, for instance, num.append np.max of array. Okay. So now if we run this, here we'll get 3 measures. Now this one was not printed, so to print that max, we'd do a similar thing. We would put this after here. This would just be max here. And here we would change the format, and we need to access the second value that is generated. So now we can look at this, and here we'll see 271. So I think if I change it this way, we get, the decimal equivalent. So see, now I've added that. Okay, so now we'll move forward and look at some more detailed examples.
We're very fortunate to have our course assistant, Belinda, to share some ideas with us. And we'll also follow up with a few pointers on Lab 4, as we know that people are working to finish that. But we want to remember that the Olympic mini project is coming along, and some may already be starting, but certainly on Thursday we'll all be starting that. So without further ado, can turn it over to my colleague.
Oh, hello everyone. So I'm just going to try and share my screen. Is that good?
Looks super.
Okay. So I'm just going to give a few tips on the Olympics project, because for the previous lab reports, we've been working on introducing a certain topic and then guiding you on how to use that. But in this project, you're basically now bringing in all what you've learned previously and putting in together to answer some of the questions given a certain data. So in this case, as you can see, we have a very big data, like it's long. You cannot get a sense of anything looking at it like this. But now, based on the various functions that we've learned, we can now be able to sort and analyze this data in a better way. One thing to note is you can see this gives you a sample of what is contained on the table, and you have to note like there's like an ID. Each athlete has a unique ID number, and then there's the name of the athlete. Some athletes have the same name, so you have to also consider that. There's the sex of the athlete and all those variables there. And this is now our data. But you can see we have various variables, so you can decide to sort these so that you can analyze based on whatever you want to look at. For example, you can decide that you want to know, let's say how many male athletes were there. You will have you'll use the table format because it's a table, athletes. Athletes, let me just call it male athletes so that we know. Then you call your table, then we let me just create a new one here so that we can do this together. Athletes, so male athletes. If we want to find how many if we want to have these based on just the male athletes, we'll say athletes dot where the sex is just M. So if we print that out, copying, it's going to, so if you print that out, you're going to see that you now have a table that only has the male athletes. You can see this one had several rows over 200,000, and this one has like 196. So you can see the females are omitted. So from these, you can now do dot numbers, and now you can know the number. I'm not sure if this is going to run. It's still running. So you can be able to know the number of male athletes in the whole, okay. Let's try again.
Occasionally with this data set, because it is so huge,
Yeah.
we can run into situations where the data set is so large that it takes up all of the memory. And then
Okay.
when we make a copy of the data set, for instance, the athlete's male, it can consume all the memory. so
Okay.
so that
Okay.
might be what's happening.
What's happening? Okay. So yeah, you can decide to just take a chunk of it, like maybe the male or the female. You can also decide to look at the age of the various athletes to see or even find the average age of the athletes. But one thing you have to keep in mind, for example, if you're looking at age, you have to remember that the name, one athlete might be taking part in various sports. So maybe their name is appearing more than once. So you have to consider that you either use the ID, which is unique to each athlete, or you can either just use dot unique. We have a function called dot unique. You can use that where it just picks one. So if the name is being repeated, it's not going to count it twice or like 3 times, it's just going to count one name once. One other thing you can do is use the dot group. I think you can use the dot group so that you can be able to see, like, for example, how many sports are there. You don't have to go through the whole table. You can use the dot group to see how many sports were played. I think this is good because I had already run it before. So you can see there were 56 rows plus this, you can see it's around 60 something. You can be able to see the type of sports that were there and how many times it appeared. So that's how the dot group function will work. You can use the dot pivot function where you can be able to compare, like, for example, a certain sport compared to the sex. So you can see like the archery sport had like 1,015 females and 1,319 males. So you can compare that and see how what sport has more females than males, or what sport has more males than females. And yeah, you can use that to just analyze your data. You can also use a function. You can also create functions, as we've seen in lab 4, and apply them. You can take out, let's say you can take out the edge. You can take out dot column and take it out as an array and find the mean. And then you can use that in a function. You can create a function that finds that. I'm not sure if I have a function here. I wanted to create a function that finds the sport and the year, but I think it was just taking more storage space. But yeah, you can create a function that can use like the mean, median. It can give you the mean, median, and the various variables, so that you don't have to repeat it again. So if you want the mean of the age, you don't have to repeat the same function for the mean of the, let's say, the weight. You can use the same function for if you are planning on repeating the same thing. Yeah, and then we had there is a challenge question for that, just putting it out on the floor, where they ask you, because it's a table of various sports and various countries participating, or various teams participating, various years. So they ask you, does the host country team have an advantage? To get this, you may need to create another column in the athletes table with the team name of the host country. So I think for this, I'll just suggest maybe you can try and see, because they ask you, does the host country team have advantage? That means we are looking at the medals. So you want to see if a certain country or certain team is, if in a certain year, the hosting city, its team, if its team is getting more medals during that year. And when you look at medals, you have to make sure that this none is not an integer. So you have to make sure you remove the none, so that it doesn't give you an error, because if you just need the integers, and for removing these, you will have to use dot where, let's say dot where medal is not equal to none, so that you just get the gold and the bronze. Yes, I think that will be the summary and just the tips of how to go about this lab. It's an interesting one, because it just gives you, you get to now you decide on what you want to use, what part of the class so far, what you've learned, and how you can use it in solving the problem. Yep.
Super. Yeah, that's a super overview of the lab. It's a lot of fun, and the good thing is you get to kind of build momentum. For instance, using the group and pivot. The challenge we ran into, it's almost good that we ran into it, because then you can see how that can happen. Because the data set is so large, it begins to overwhelm the memory of the virtual machine at the Amazon web server, and then the kernel crashes. But there, I think word to the wise is if one makes copies of the original data set, for instance, Belinta was really nicely demonstrating the idea of creating a sub-data set that was simply for the male athletes. But unfortunately, that database was almost as large as the original file. So then the amount of space required, memory, almost doubles.